Hello everyone, and welcome to another Motec webinar. My name's Pete Swinney, and today's subject is how to configure an SLM into an ECU. Thanks everyone for logging in, and without further ado, we'll carry on. In front of you there today, you see some pictures of one of our Motec SLMs. It's a shift light module, and the page in front of you there just kind of shows you the different configurability that the display has. 8 lights in a row, and they're able to become one of 8 colors as well. Today we're going to talk about how to connect an SLM to an ECU, what it is, how to wire it, how to get it to communicate with the ECU, how to configure it to show different things, and some different examples that might get you thinking about the possibilities with one of these products on vehicle or engine. What is an SLM? The SLM is a CAN device. It's a device that is kind of a standalone computer on its own right. It has 4 wires going to it. 2 of them are simply the power and ground, and the other 2 wires are a little bit like the blue cable that's on most of your PCs at home or in an office. It's actually a communication pair of wires. So what actually happens is that the shift light module talks to the ECU, and the ECU talks to the shift light module on over their own little communication network. That means that we're able to do lots of different things with the colors, intensity, and when to turn lights on and off without having a whole lot of different wires. And normally you might expect that a device like this might have at least 8 wires for 8 lights, plus a power and maybe extra crowns and things. So in this case it's a CAN device, and so it only requires those 4 simple wires. Makes it easy to wire and put on a steering wheel or somewhere up out of the way on a dash, and you don't have to have a big wiring loom. Each of the lights can be 8 different colors. So the list of which we'll come to shortly. Basically, by entering a number in a table in ECU Manager, we can tell the shift light module what color we want each individual light to be, and the table will also tell us when to turn those lights on and off. So how to wire a shift light module? When you actually purchase it or you get your dealer to install it, there will be an installation document with it, but it is very, very simple. Effectively, you have a power and ground wire, and normally would be terminated back at the ECU, and then you'll have what's called the CAN high and CAN low. Now normally we like to wire our CAN low wiring with a green wire, and the CAN high wire with a white wire, but in this case that wouldn't have shown up very well in my presentation. So we've used a yellow, and some wiring guys do use yellow as CAN high. The only other thing to be very careful on when you are wiring a CAN device is to ensure that the wires are twisted. This helps to cancel out the noise that is created when you have a lot of high-speed electricity flowing backwards and forwards. And we like for them to be twisted at a certain rate. Now, full details on how to do a proper CAN bus wiring, it can be found in a number of our manuals, and the ECU and data logger manuals give some good detail on how to do that. For a simple installation such as what we've got here, the ECU, which might be in the footwell of the vehicle or down the back of a PWC or a boat, and the shift light module will simply be a 4-wire loom up to wherever you want to see the shift light module itself. So simply twisting the CAN high and low wires themselves together, and then having a 100 ohm terminating resistor certainly at the shift light module end is the best way to ensure that the system will work correctly. Each of our CAN devices, just to note, depending on the CAN bus design, can potentially have the need for a 100 ohm resistor to be placed at that point. But as a result of CAN bus design, it may not be required in each case. So we don't put 100 ohm resistors on any of our devices. It's up to the wiring design guy or the person making the installation to determine where to put these terminating resistors. If the CAN bus is over 500 millimeters in length, and in most cases that would be the case for most installations, you will need a second terminating resistor down at the ECU end. So again, if you find that a little confusing, there can be details able to be found in the ECU and manuals. Okay, so assuming you've got that wired correctly, you would want to then set up in the ECU manager how to configure it and make the lights go when you want. The setup for the shift light module can be found under General Setup, Communications, Light Module, and then the setup, of course. Once you're there, you end up with some parameters to put settings into. And the first one is a convenient little feature that we allow the driver warnings to be displayed on the shift light module itself. Now, the ECU manager has a feature where you can configure an auxiliary output up to turn on a light when any of the ECU sensor parameters exceed their diagnostic high and lows. So for instance, if we have a map sensor that is a 3-bar map sensor and the engine overboosts and puts the map sensor into error, we can have that warning come up on the shift light module by the driver warnings feature. And similarly, if we set up an alarm in our engine temperature sensor setup, whereby if the temperature, for instance, exceeds 105 degrees Celsius, that alarm is triggered, and the shift light module, if we set 1 in this instance here, will illuminate the two either end right hand LEDs to red. That allows the driver to obviously see there is an issue that he needs to deal with, and it negates the need for a separate warning light. You do need to, though, however, even though you're not using an auxiliary output to drive a warning light, you still need to configure the warning alarm function in the auxiliary output setup. So that's something that you'll need to do. So the next parameter we're going to configure is the intensity. Now, if you haven't seen one of these things going, take it from me that don't necessarily assume that 100% brightness is what you'll require. I've seen drag cars tearing down this drag strip with these things on, and you can clearly see shift lights going from the crowd. And in some cases, 100% will be too bright for some cases. Certainly in low ambient light and at night, it would be almost blinding to use 100% intensity. You have a couple of options here. You can put in a preset number to give you a preset brightness, and that will always be the intensity of the LEDs. And so that would suit an application whereby, let's say, you will only ever racing in the day, and maybe an example of a boat or a jet ski or something like that, where it's always bright outside, so you possibly might want to enter the number 100 in there. If it's more of a car or a streetcar installation where you're going to be using it at night or in low light applications, you can actually tie the intensity to one of the user channels. So we could configure a switch or a dial onto one of the user channels, and then you could adjust the intensity just like some of the cars used to have in their dashboards. You could adjust the backlight up and down in the dashboard, where you could have that same dial adjust your intensity up and down so that your shift light module was not blinding you at night. The next adjustment is the filter. A lot of people don't even necessarily play with this. And this really depends on what you are using for the y-axis on your shift light module. The shift light module itself, even though we call it a shift light module, can be used for almost anything, any channel in fact. And a lot of my background is actually not to do with cars and more to do with boats. So boats don't tend to have gearboxes, so we don't use a shift light function at all. And if we're using the shift light monitor for module for things like RPM or manifold pressure or boost, or throttle position, things like that, sometimes the channel that you're using moves a little quickly, so it needs filtering so that the lights aren't flashing all over the place madly. So you can enter a number between 0 and 50 here, or between 1 and 50, to help stop erratic flashing of lights. And certainly you would use this potentially in the case of RPM. Manifold pressure sometimes is quite erratic, and we don't necessarily want lights going off for a very, very small spike of overboost. This is potentially something that you'll need to do on a trial and error basis, so just play with the number to get nice, sensible operation of the light module. Last parameter to adjust is the hysteresis, and this is a little bit hard to understand for the newcomer, but the example on the right, as with a lot of our help, is quite useful. So in this example, we're using the module as a shift light module, and therefore the y-axis might normally be RPM. So we're actually wanting to turn on lights at different RPMs. So in the case here, if we set a 500 hysteresis, that means for a given shift pattern of 10,000 RPM, we need to come down the hysteresis number of 500 before the 10,000 RPM light will fall off. Right, so it allows a little bit of plus minus. So if I wanted, for instance, a light to come on at 300 kPa of absolute pressure, so that would be 2 bar of boost or 28 pound of boost, and I put a hysteresis number in there of 2 psi, that would mean it would have to fall from 28 down to 25 before the light came off. So again, it allows for some stability with the lights and allow them to basically come on and stay on if it's in the ballpark of the number that you're after. And also, again, it's something you might want to experiment with. So next thing to do is to set the table up in the shift light module setup. So again, that's just simply underneath the setup parameters, general setup, communications, shift light module, and table. Now in an ECU, our setup's relatively clamped compared to a shift light module that's driven out of the dash. The ECU manager has only limited flexibility, as I said, with regard to this operation, but there's still some reasonable amount of use you can get out of it. When we get to the shift light table, we're presented with a simple 2D table initially, and basically each of these numbers represents the light that you see in front of you on the module itself. So Number 1 here is the first light you see, 2 is the second light, and 3 is the third light, etc. And you enter into the table a number that represents the color that you want to be on that light. So we'll see the help on the colors shortly. But I can tell you, if I put a 1 in here, I will get a red light. And if I put, say, a 4 in here in the second light, it will be green. Now, as it is, the table's not complete yet because we don't have a vertical axis, which is an axis that's going to change and give us color or light changes. So our next thing to do is configure that vertical axis. Right, and as with all tables in the ECU manager, we want to choose a channel, and the easiest way to get to the axis setup is just to push A for axis. You can also right click on the table and choose axis setup as well. So once we're in the axis setup here, we can turn it on by checking the enable axis box. And then if the RPM channel, which is probably there by default, is not the one you want to use, you select and go and choose from all the other channels available, which is in the hundreds, the channel that you want to use on the vertical axis of the table. Now we end up with a 4-level vertical axis, so we only get 4 different rows to program. So each of those rows you can enter a number that you want to make a color change at. So in the example here, I'm going to get my driver to shift at 7,000 RPM. But at 6,000 RPM, I'm going to give him some warning that it's going to be nearly time to change. At 6.5, I'm going to change that warning. And at 6.7, I'm going to say, look, buddy, get ready. And then at 7,000, I'm going to give the big flash of red. So you enter into the table the numbers where you want a light change. Then we'll end up with something that looks like this. And at this point, you'll have the table configured, but there'll be probably all zeros here. And you're going to go, well, what blazes numbers do I put in here? How does this work? Well, what happens is if you press F1, as per all tables in our ECU manager, you'll get some help. And in the help, you'll see that for each number, there is a corresponding color. So as I said earlier, 1 equals red, 2 equals orange. You can see that for any given number that you enter in the table, you'll get that color on the shift light module. So in our example, at 6,000 RPM, the number we will get, the first 2 LEDs on the left are going to go color 3, which will be yellow. At 6,500 RPM, we're going to have yellow on the first 2, and then the next 2 will go orange. At 6,700 RPM, we'll get yellow, orange, and then magenta. And then at 7,000 RPM, the whole lot will switch to red. So we get a progressing 2 lights coming up across the right-hand side of the shift light module, changing colors as they go, and then all of them going red when we get to our actual shift. Simple enough. Another example here is the table is configured as a boost gauge. But in this case, we're actually using the boost gauge as a means of telling a rider, in this case, of when he's at an optimal launch boost. In this particular application, it was actually a jet ski, turbocharged jet ski, and those things will start on the start line at no more than 2,200 RPM. Now, turbocharged ones, the customer will increase the throttle to try and build as much boost as possible, but if he builds too much, it might break away and he might jump the start. So we configured a shift light module onto this jet ski. This particular one doesn't have a dash on it at all, so this kind of becomes a fully configurable dash for that client. And now on the start line, as he increases throttle and the boost begins to build, you can see that coming up in the way of the lights. And like the last example, we did an increasing or a changing color as the boost comes up, and also the lights go across the same way. But instead of this time it being red when it was time to leave or time to shift, we made it number 4, which if we go back, is green. So in this case, when the shift light module goes green, he knows he's at the launch boost required. Last example we've got today is again a shift light module used as a launch assist tool, but this time the example I had was for drag racing. Commonly in drag racing, customers will need to sit at a particular throttle position, and the vehicle will leave the start line particularly well at a particularly good throttle position. And it's certainly difficult to even see that even on one of our dashes when you've 2,500 horsepower drag car sitting on the line vibrating and making smoke. So a shift light module mounted on the steering wheel allows the driver to see when he's in the right zone. Now in this case, as he starts to increase the throttle, we've got all the lights being used across the full width of the shift light module. And we see that we have a yellow, full set of yellow, then going to a full set of blue, and then going to the full set of green. Now when he's in the green zone, I would tell the driver that that's the correct throttle position, because we've done testing previously and we might have decided that 40% was the correct throttle to launch at. And then what we've done, if he goes too far, is we've allowed him to see that he's gone too far and past the optimal launch throttle position, and the lights will go red. So when he sees red, he knows that he can just back it down until it goes green and he's right in the zone. So the shift light module allows some very accurate information to be displayed to the driver, but using very simple terms like some simple lights. But he can potentially get throttle position to an exact percentage using this style of method. So simply a matter of changing the vertical or the y-axis here to the channel that you most want to display to the driver. Go from there. Well, that's it for today, and thanks for everyone tuning in. This webinar will be up on our website within half an hour, and we'd like you to offer it to anyone else to come and download it and look and learn. Plenty of other subjects there for people to look at, and it's something we're going to build on over time. Any questions, I'll leave the meeting open for, and otherwise we'll see you next time.